In this video, I'm going to demonstrate two functions to compute the Fibonacci sequence or Fibonacci numbers. And I'll kind of show you the time difference versus computing it exponentially or linearly. It's pretty cool to see how the way we compute things can really affect the amount of time it takes. I mean, there's many ways to go about processes, but finding the fastest one is very beneficial. So let me turn the camera around. Here's a picture of Leonardo Fibonacci, the guy who created this algorithm, and you can do like a quick Wikipedia search about him and learn some more. He was a traveler from Pisa, that's what it says here. But anyways, pretty much what happens with Fibonacci numbers is they kind of just get bigger, but they get bigger in a certain way, okay? As you notice, each of these sections is substantially larger than the previous one. If you notice, 3 plus 2 is 5, and 5 plus 3 is 8, and 8 plus 5 is 13, and you guessed it, it just keeps on going on and on and on. That's why it's getting bigger like this and kind of spiraling outward. Here's a little addition chart, I guess you could call it, of how that works. So we start at 1, and we take the previous number and add those together to get our current number. Okay, so 0 plus 1 is 1. All right. 1 plus the previous number, 1, is 2. 2 plus the previous number, 1, is the next number, which is 3. Okay, and that keeps on going, all right? So that just keeps on going, going, going. Now, there are two ways to compute this that I'm going to demonstrate right now. I'm sure there are other ways. And real quick, let's just run some code. Okay, I'll kind of get rid of this. So we'll run that. And if you notice, the first time I compute it, I use a linear program. Okay, so I compute 35 Fibonacci numbers, and it took a fraction of a second, very short amount of time. But with this exponential function to compute a Fibonacci number, it takes much longer. Okay, now let me explain real quick the difference is between these two functions. The Fibonacci numbers being computed exponentially basically has to recompute all the previous ones to find the one it's printing out, okay? Whereas the linear one, it remembers what the previous numbers were to compute that, okay? The exponential program, it is done recursively, okay? And the linear one is done using a list where it can save what the previous numbers were and then use that to compute the next one. So that's why it takes very little amount of time. Okay, whereas the exponential one is not saving any information at all. Okay, huge amount of processing going on. All right, so the exponential function, this one here, took about 45 seconds, almost 46 seconds, and it was just, I mean, a little bit different on that time there. And basically, it took so much longer, and here's a little like diagram of why that is. So the recursive one does this. It goes, and for every time it has to recompute. Okay, it has to go out and do that, whereas with iteration, we can say what the previous one was and continue onward. All right. These are kind of what the graphs look like. In fact, here's a better graph of that using Big O. Our linear program looks kind of like this, but our exponential one just goes whoosh. And you can tell that as x gets bigger, it takes a lot longer to compute these numbers using Fibonacci. Okay, I'll leave this code in the description so that you can be able to access it. It's just on REPL. You can copy it, do whatever you need with it. Hopefully this was a little educational and informative. Anyways, thanks for watching. See you later.